fed, let me get started. I am Sonam. I am part of the AI Camp team, and my friend here, Kalyan, whom I cannot see where he went. Okay, yeah, he's waving there. Say hi. He is also a part of AI Camp, and so if you don't know what AI Camp is, so we are a developer community, and we have over 350,000 AI developers in 150 plus countries. And all these red pins, we actually have chapters there, and we are running all the events, hackathons, workshop, you name it. We are spread all over the country. And how could you get involved? Well, there are different ways you can do it. You can submit topics to speak, and you will get a chance to come up here and give a talk. You can sponsor the venue or sponsor the events, more food, more beverages, prizes, and so on. Or you can also collaborate on events with us. And if you have any other ideas, or if you like these ideas or options, please feel free to email us at info@aicamp.ai. I repeat, info@aicamp.ai. We have been hosting a lot of different events pretty regularly. We have virtual seminar weekly on Fridays. We now have today's event is on June 4th, and my bad, I did not correct this one. But the next one is on June 13th at Microsoft's office, and it's a workshop. So please register and come. And if you are aware of AI Camp events, and if you've been to Microsoft Office, please make sure that you register, because their security is really, really tight, and the QR code is a mess. So please register now. The next hackathon, and by the way, we have successfully hosted the last 2 hackathon, and it was wonderful. And the next one is coming up on June 29th at Cloudflare's office, which is, I think, around the block from here. And all the details you can find on the AI Camp website. More up-to-date details will be all over there. And this is my favorite slide of all our clients and sponsors, which is wonderful and very colorful. So thanks to all of these. Community shout out. So I am going to give 30 seconds to a few people. If you are hiring for any role, if you're looking for a job and new opportunities, or if you're looking for project collaboration, co-founder, and such, please raise your hand and I will give you the mic. Are you guys shy? Don't feel shy. You can speak up. All right, okay, moving on. So these 2 QR codes that you see on the slide, one will take you to our Slack channel, and the other one will take you to our Discord. Feel free to scan and join. And if you have any questions, and since you guys are feeling so shy today, you can post your message there on Slack community or either of those. I'll give you 10 seconds. I see some mobiles going up. And your time's up. All right. Thank you so much to all the sponsors for today, Aerospike, Kùzu, and of course, GitHub for this beautiful office, and Korbit.ai. That's it. And we will get started with our first talk of today from Aerospike. Let me welcome Art. Hey, Art, give it a round of applause. Do you want handled or?
Yeah, that's fine.
Leave it here. It's on.
All right, cool. Thanks. So yeah, my name is Art Anderson. I'm with Aerospike. I'm part of our DevRel team. So I do a lot of work in kind of implementing Aerospike in real world examples, building demos, things like that, and just trying to make things simpler for our developers to build with Aerospike and understand our software. So what I'm going to do today is kind of take you through a bit of a journey that I went on recently. So Aerospike, we are a database. So we're a NoSQL key value store, super high throughput, low latency, all that jazz, right? But we got into the vector space recently. And so I was asked to create a RAG application using our vector database. And so with next to no knowledge about a RAG implementation, I decided to go in and build it. And I'm going to kind of just walk you through what I went through, some of the pitfalls and things that I discovered along the way, and kind of give you a little show of what was built, and then maybe answer questions. So first off, what is RAG, right? So this is retrieval augmented generation, right? This is effectively augmenting queries with context to provide an LLM with additional information, right? So if I ask a question to an LLM, it's going to give me an answer based on its training data, right? So when you train like a foundational LLM, it is from a very specific date backwards, right? So imagine if you stopped learning today, and then a week from now, somebody asked you about what happened tomorrow, right? You wouldn't be able to answer that question. And so with RAG, or retrieval augmented generation, we're basically passing along new information to the LLM so that it can inform itself to then create a better answer for you, right? So you're almost like passing along the answer to the LLM and asking it to summarize it so then it can give you a better answer when it might not know or have the appropriate information, right? So this is going to be super helpful in preventing hallucinations, adding domain-specific knowledge, avoiding stale trading data, all that good stuff, right? And we're going to talk about this kind of like little life cycle here. And if you're familiar with RAG applications, then this might be a bit of a review, but I'm going to kind of talk about what I ran into as I went through kind of each of these steps. So the first thing that I had to do was I had to load data into my vector database, right? So first things first, what kind of data am I working with? What is a vector? What is a vector database? And kind of all of that, right? So I decided that I was going to take all of Aerospike's documentation, right? So our doc site, we have a developer hub, bunch of code samples, blogs, white papers, all of that. And I said, I'm going to take all of those things and I'm going to create vector embeddings on them, and then I'm going to store them in our vector database. So the documents themselves, I had to go through a process of kind of prepping them. I had to identify kind of how I was going to go about creating these vectors, and then figure out kind of how I wanted to store this information within the database. So the data itself, right, like I said, this was basically all of the Aerospike documentation. So I had to take each one of these pages and break it into smaller chunks, because as I'm passing along information to the LLM, I have a very finite window of tokens, right? Or basically like parts of words that I can pass into this. So I want to try and get really like as distilled down the information necessary to answer this question with as little data as possible. So I had to come up with a way to break these documents up. And I'll be honest with you, like it took me 20 minutes to get an LLM up and running locally and start talking to it. That's like the easiest part of this whole thing, right? This was what I spent more time than anything else on. How do I chunk this stuff up? So I ended up coming up with an incredibly complex algorithm that involved me counting to 2,000 words. And then creating a vector and then moving on, right? So it was super simple, not the best implementation, right? So there's a lot of different ways that you might go about chunking up this data. I might use vectors to identify semantic similarity between each sentence. And when I get to a large similarity difference, then I move on to the next chunk, right? Counting, using an LLM to then decide where the different pieces of semantic meaning and all that stuff and context live within that. It's really important though that you identify a good chunking strategy, because like I might be in a document reading and paragraph 4 could potentially have really no context about what I'm talking about in paragraph 3 and paragraph 5. But because I'm in the document and I'm reading it and I just read the information before and after, I have that context necessary to understand what this is talking about. The LLM doesn't, if that's what I'm sending over. So I might want to overlap some information in these chunks and so on. So incredibly complex, took a very long time. And then I finally got to where I was, where it was working okay. And I needed to really identify a good embedding model, right? So what's a vector, right? A vector is just a list of floats effectively, right? In a very simplistic way. But this is a way to capture the semantic meaning of the text, right? So I'm going to use these vectors within my vector database to do some kind of similarity search, and then I'll be able to return back the information from that document, right? Those chunks of data to be able to then pass along to my LLM. So I ended up going with Demystified, but this was not the first one I looked at. I looked at a handful of different embedding models, but this one really worked best. So one, it has an 8K context window. So that's pretty darn big, especially for these smaller embedding models, because it's only about 500 megabytes in size. So it's pretty light to run. You can put pretty large chunks of text into it. And then you have the ability to kind of fine tune your dimensions, right? So how big these vectors are. I can go with the default 768 dimensions, but I can slice and dice this up using this Petrushka, something, whatever, math, right? I can apply math to it and I can get smaller dimensions. I didn't do that. I stuck with 768. But like I said, it's a small footprint. So it runs quickly and it does a great job. It's also specifically built for larger text embeddings. So I had basically a prefix on all of my documents. And then when we get to query, I have a prefix on query. So it's able to basically identify like when I'm looking up a document and when I'm actually creating an embedding on a query, right? So the vector database, well, if I didn't choose Aerospike, I probably would have gotten in trouble. But this is what I chose here. Aerospike, we're using the key value store really as the backing for the vector store. And then the Aerospike vector search is a kind of in-memory cache, if you will. So this is where our HNSW algorithm is running. It's building this graph to be able to traverse and identify and do all of the similarities. So things like cosine similarity search or Euclidean distance. We're able to do this very quickly and get pretty darn good results. So after I got all my documents chunked up, I created the vectors. I then stored that information inside of Aerospike, right? So like I said, Aerospike at its core is a key value store. So what's actually happening here is when I was saving my vector, I was also saving the document text. I was saving some metadata about the document, like URL, description, title, all of that, all inside of a record within Aerospike. And so what that did for me is on retrieval, made it very simple, because when I'm returning those search results from my vector database, I'm actually able to gather that data immediately and then pass that along to the LLM. All right, so now that I've got data in my database, right, the actual application is really about answering user queries. So I have my pipeline here for when somebody asks a question. Now, I use Demystified, like I said, to generate embeddings on the document chunks. I'm going to use the exact same embedding model to generate embeddings on user queries. So somebody comes up, types in a question, right? How do I do X, Y, and Z in Aerospike? I then send that over to my embedding model, generate the embedding, send that over to Aerospike where I do a cosine similarity, and I'm going to return back like the top, let's say 5 results. Then I'm going to pass that back up to my application where I'm then going to engineer a prompt. So I'm going to take the user's query, I'm going to take the context that I've returned back from my vector database, and then I'm going to pass all of that over to my LLM. Now, for this project, I'm using Google's Gemma. It's their open model. So this is a 7B instruct model, 7 billion parameters in there. It's fine-tuned for conversational type use cases. And so worked really well for this. It's also fairly light compared to some of the other larger models. So prompt engineering, right? This was something that I would have never even given any thought to at all. And then started doing this. This is really hard. Prompt engineering is a real job, and don't let anybody tell you otherwise. This was probably like version 20, something like that, right? Over and over again, trying to get the best results I could. How do I build good guardrails that I'm not going to let the LLM hallucinate, but I'm not going to make it so tight that it can't answer any real good questions or anything like that. And so this is what I ended up with. This is actually the prompt that the RAG application I have is using. And that's it, right? I'm just saying, hey, you're an assistant. Here's the context. Here's the question. Can you give me an answer? And it actually does a pretty good job. Now, like I said, the large language model that I'm using, Google Gemma, 7B Instruct, another 8K context window when we're working with this. I did quantize this with, or down to 16-bit floats. So the original model is 32-bit floats. That was too big to fit into memory on one GPU. One GPU on Google's cloud costs a lot of money. So trying to get it as cheap as possible. So the precision on this is a little bit reduced, but perplexity is largely unchanged. So the results are really good, right? So like I said, sending the engineered prompt, combining the query from the user with the context from the vector database, we send that back or send that over to the LLM, and then we stream back a response to our user, which ends up like this. So this is the actual application here. And I'm just asking it, how do I create a secondary index with ASADM? This is a Aerospike tool, right? And so what happened here is in about 10 milliseconds, it was able to go in, return back to me. Now, it looks like it only returned 4 documents. It returned the top 5, but I'm doing the unique documents return. So 2 of those chunks were from the same document, right? And then it generates a response for me, right? So it's streaming this back and letting us know what the answer is and how to do that. And that is actually correct, which is pretty cool, right? That's the goal. So yeah, so that is basically getting us to our finished product, right? There's our RAG. We've retrieved some documents, we've augmented our query, and then we've generated a response from the LLM. Cool. Questions? Yeah. Oh man, what do I wish I would have known beforehand? Well, so, it's very interesting. Before I got into the world of databases, I used to do a lot of work with convolutional neural networks and image recognition. So when they were like, hey, we got a vector database and we want you to do this stuff with the RAG and LLMs and all that, I was like, it's nothing, right? Totally different. A whole different world. Image recognition and responses from the LLM are so different. I didn't realize how much I would have to spend, or how much time I would have to spend just talking to the computer like a human. That was weird. But the more that I did it and the less I cared about that, the better my results became. So that was very interesting. I probably could have saved a lot of time with that. Also, going into the chunking strategy and not realizing how difficult that actually is, how big of a problem that is. I spent a lot of time Googling, right? And then the whole internet is just awash with people trying to solve that problem, but nobody's actually solving it. It's just, we tried this and it kind of worked. And it might work for you, it might work for this. Yours might work over here, but not over there. It really depends on the data. And I even have stuff within our documentation that's not quite in the same format as everything else. And I don't know what to do with it yet, right? I don't know how to fit that into the database or really into that set of vectors to be able to search it in the same way that I do the other documentation. So yeah, just lots of little things that I would have never thought about, oh, this will be easy. I'm just going to scrape the web and pull some stuff out. So
the question, can you recreate what you did from scratch to get the same thing?
like right now, if I were to run that same query.
No. If you generated the database, if you went back to the beginning and what you wanted to do was see if you could replicate what you've already done.
Oh,
Is that,
I think so.
so it wouldn't matter what the word, what the data in.
Oh, well that, no, okay. So if you didn't hear the question, if I went back and I tried to just do all this over again, would I be able to like replicate it regardless of chunking strategy and all that? No. If I did exactly what I did, absolutely would I be able to replicate it. But if I chose a different chunking strategy, if I chose even just a different number to count to, I'd probably have very different results. When I very first started, the first embedding model that I used, it's like, I mean, it's the one you see in like every RAG demo that exists on the internet. I can't remember what it's called, but it's a very simple one. And I thought I was getting pretty good results. Like, this doesn't seem terrible. And then I actually started reading through their Hugging Face like model card. And I found out that they're just truncating everything after 200 words. So no matter what you put into it, after 200 words, it's just gone. And I'm throwing thousands of words into this model thinking that it's going to give me good results. And that wasn't the case. But I perceived that I was getting good results. I even tried, so there's Doc2Vec, which is an implementation of Word2Vec, which is a Google semantic kind of word model. And with Doc2Vec, you can actually take your own kind of training corpus and build your own model, right? So use their algorithm, train your own model. And I was like, I've got about 4,000 documents here after I chunk everything up and set it all up. Maybe I'll just build my own model. Well, not even close. Like maybe if, times a million, then I'd have enough data to actually train a good model, right? So there's, so many variations and different things that I could have done to end up here, but maybe not exactly here.
How do you know
I mean, that's a very interesting question. How do I know how close I want to get? Right. So there's a lot of ways to kind of look into really like how good is this, right? And honestly, I think one of the best ways is just to get sentiment scores, right? I ask it a question or somebody else comes in and asks it a question, and then I ask them, what'd you think of that answer? Did this help you? And then you can go back and fix some of these things, right? Training these models, as far as like the LLM is concerned, could be very time consuming, but training your index, right, within your semantic search or augmenting that slightly isn't nearly as heavy. And those are things that you can do kind of iteratively one after another. Yeah.
Follow up on that. If one of your experts wrote the documentation and all that comes and plays with this and says, yeah, that's wrong. It should be, it should be a different answer. What do you do to change the system to get answers that you would like to have?
So yeah, so great question. What happens if like the documentation is wrong? Fix the documentation. So yeah, that's a great question, right? How do I get it out of the database? So what I've been working on as of late, right, is taking this and actually replacing our website search, right? So when you go to aerospike.com, you can search documents and all that kind of stuff, and it's okay, right? This could be much better. But if things change, right now I'm scraping the websites. I need to scrape the websites like every night, right? And then I have to go through and I have to maintain an index on how many chunks each document are creating. And then from there, I have to remove any, extra chunks. That's it. I mean, it's literally just tracking and making sure that I'm not duplicating or really leaving old data inside the database. Well, it's a lot of little scripts here and there, right? We'll go here and then over there, yeah. Yeah. Yeah, reg is dead, right? Yeah, all these massive context windows. Who knows, right? there are a lot of them. Those are incredibly expensive to run, for one. And then even like the APIs could be prohibitively expensive. You know, like I said, I'm running this on like a single GCP instance with one GPU. The RAG helps with that quite a bit. Like, you know, if I was to try and fine tune this, it would take a lot more time on my documents and all of that kind of stuff. I don't think that with all of these massively large context windows coming out, that RAG is necessarily dead. Really what that says to me is like conversation is now possible in a RAG, right? So like I have 8,000 tokens that I can work with here. That's all of my context, that's the query and the response back from the LLM, right? So on average, I'm getting about 7,000 tokens with each question. So I don't have nearly enough tokens left over to carry on a conversation. And the second that I hit that window, right, the LLM has forgotten everything that it was talking about just the moment before. So with a million token context window, that means I can have that conversation with my RAG, right? So it just kind of adds, I think, another layer to all of it. Yeah, we're gonna go over here real fast, and then I'm not sure how much time. We're good. Okay.
Proper names or words that you don't have correct embeddings for. How do you deal with that?
Say that again. Sorry.
About proper names or words that you don't have correct embeddings for.
So yeah, proper names or words. Are you talking like in the vocabulary of the LLM?
You don't have the embeddings model. You don't have those words in the training set.
So I honestly haven't really run into anything with that. There's definitely a case for, especially on embedding models, because a lot of them are so much smaller. Fine tuning can be a lot simpler, faster, less resource intensive. So in adding to that, the vocabulary and then retraining the models or fine tuning on that could be helpful. I will say, however, Aerospike is a company, let's earmuffs over there. We do a terrible job at naming things. So we use non-conventional names for lots of things within our software. And I haven't really run into issues with this. So I don't know how much of a problem it would be, but I think that like fine tuning and training on those embedding models would be super helpful. Yeah.
Okay, we have one more question and then.
Yeah.
Doing a proof of concept is pretty straightforward for RAG, but going to market's different. And I'm curious as to your strategy and what dials, everything from chunking to re-ranking, did you use to finish your product? And
so, well, first off, I wouldn't call this a product. The vector database is a product. My RAG here is a work in progress, right? But the dials were all over the place. So with the chunking strategy, that's probably where like the most turning was happening. So not just how am I breaking up the documents, but also which embedding models I was using, right? Playing around with those quite a bit. I did switch LLMs halfway through as well. So I started this with Llama 2 70B, but I was doing using a quantized model down to 4-bit in. So massively smaller than the original model. I did use the 13B model as well, and then switched to Google's Gemma model solely because we were going to Google Cloud next and they wanted to show this off there. So that was something that I definitely noticed going from Llama to the Google Gemma model. There were some, I would say, significant changes. I did actually have to go in and like rewrite a tokenizer because I was getting some really weird results as far as like how it was returning information to me. So basically like decoding the stream coming back from Gemma versus what I was seeing with Llama. Yeah, there was all sorts of stuff. So I would say like, if you could put a dial on literally everything I did, every one of them got turned 360 degrees probably throughout this whole process. So. Cool.
Okay, thank you. Thank you, Art. This was great. Huge round of applause. Thank
So, real fast, I just want to throw this out there. Oh, we lost the screen or something.
Tighten the.
There we go. Okay. This is a QR code for our Discord channel. So this is kind of the Aerospike developers, but the other one is for a chance to take this Saturn V rocket home today. So grab that. You feel free to hit me up as well, and I can get you this QR code if you haven't grabbed it yet. But then before we leave tonight, we'll choose a winner. Thank you.
Thank you.
Scan it, scan it. Looks like an interesting gift.
Yeah.
Come on, guys.
Go for it.
All right. That's it.
All right. Thank you. Up next is Prashanth from Kùzu.
Okay. All right. So good evening, everyone. Really nice to be here. This is a really nice office. So thank you very much to GitHub and to AI Camp for organizing this. So I'm here to discuss the role of knowledge graphs in RAG. And for those of you who've used knowledge graphs, as you know, they've been around for a long time. They're not a new entity. But in the last year or so, as you know, RAG has come to the forefront of imagination of most companies doing interesting things with LLMs. So there's been a whole circle back to knowledge graphs, and there's a whole new wave of thinking as to how you use knowledge graphs in RAG. So my talk today is slightly more conceptual, and I want people to think about ideas, take away some ideas, and implementation details and things like that are things that follow after this sort of talk. So before I get started, a little bit about me. I used to work as a data scientist and then a data engineer, and I'm now an AI engineer at Kùzu, which is a company based in Canada. I contribute to open source very regularly. So I'm happy to be here at the GitHub office, which is kind of in my home. I blog at thedataquarry.com. So some of you may have read my previous blog posts on vector databases. So yeah, I could go on all day about graphs, graph databases, but also about vector databases. So the topics here are some things that are very close to my heart. And yeah, I've spent a lot of time studying NLP and working on different data modeling paradigms. So I'll start with an overview of graph databases and the general idea of knowledge graphs. If you've seen the literature, graphs are also known as networks. And in essence, they are an abstract representation of nodes and relationships. The nodes are essentially entities from the real world, and the relationship is the connection between those entities. At a microscopic level, they look quite simple, but in the real world, as you bring these data forms together, they become really complex and reveal really interesting structures. And that leads me to this, which is graphs are a very natural way to represent data. Social networks are the most common form of graphs that we come across in day-to-day life, but they are also ubiquitous in other domains like drug interactions, molecular networks, traffic networks. In the financial world, you have transaction graphs that deal with, that are used for things like fraud detection. And of course, knowledge graphs are a sort of theoretical academic concept, but they apply in the real world in the way they are used to build these connected entities. What I want to stress on when it comes to modeling data is that data does not exist in a certain form. You can choose to model it the way you want. And these models are interchangeable. So everyone's familiar, I presume, with the relational model, which is a common form in SQL databases. So I'll start with this simple example, which is two persons who know each other, who follow each other, sorry, and they live in the city, Toronto, which is where I live. So the relational model on the left here, it kind of describes this using tables, where you have a primary key identifier, you have a person table, a city table, and you express the relationships as separate tables. And it's an implicit connection between the relationship tables and the node tables typically through foreign key relations. Now, the same data can be expressed, as shown here in the middle, as a document model. And many document databases exist where you would store these as JSON blobs. And it's a similar information, except that each entity's information is stored in a single blob. And note that there's a bit of a repetition here because you need to store the follows relationship in both directions, in both of these entities, in case one person follows back the other person. So it's a different way of representing the same data. But this leads us to the third model, which I'm talking about here, the property graph model. And that is basically the intuitive representation that I showed earlier, where a person is represented by a node, which follows another person node, and each of these persons lives in a city. So the overview of graph databases in general involves three key components. I'll start with the data model component, which I just described. The most common data models in graph systems are the property graph model, which I just showed, where you have key value representations of properties. Essentially, the property is, in this case, an ID or a name or whatever other metadata field you attach to a node. But there's also other data models like RDF, which is Resource Description Framework. It's a slightly different approach, but the idea is the same, where you have a triple that represents connections between entities, and you express them using subjects, predicates, and objects. The other key component of a graph database is the query language. Most graph database systems represent a high-level query language, similar to how SQL is in relational databases. But the query languages in graphs are designed for a graph-specific syntax. This is an example of a Cypher query in the middle, which is the language that Kùzu implements. And as you can see, if you've seen SQL queries, the way you perform joins and identify on filters is quite intuitive, except that you use different clauses like a match and a where and a return. But the idea is very similar. It's a declarative query language. And the other key thing about graph databases is the system implementation, where you use graph-specific storage structures and define specific algorithms like shortest paths that are typically not present in relational systems. So this leads me to what Kùzu actually is. As I mentioned, it's a graph database, but it's a database that's designed for analytical query workloads. And it's being built by Kùzu Inc., which is a company based in Waterloo in Canada. And the key ethos of Kùzu is that it's built with usability in mind. And using a query language like Cypher is a key step in this direction, where you have a property graph data model and you have a declarative query language, which is Cypher, on top of the graph. The other key feature is that Kùzu is an embedded database, similar to DuckDB or SQLite, if you've ever come across those systems. And the idea is that you just import the database as a module in your programming language of choice and open up a connection and begin querying the graph. Like many relational systems, Kùzu is ACID compliant. It has a permissive license. It's MIT licensed. And it's designed to be interoperable with many, many formats and other data systems, including many of the data lakes and relational database systems out there, as well as structured CSV files. But also, it's meant to be integrated with the core AI and data science frameworks in the Python ecosystem. So we currently support integrations with NetworkX for graph algorithms, PyTorch Geometric for graph machine learning, and of course, LlamaIndex and LangChain for working with AI-related applications downstream. The other key thing about Kùzu is that it aims to be very fast and scalable, and to represent the state of the art of how graphs should be stored, indexed, and queried. I can't go into all of these details, obviously, in this talk, but we talk at length about some of the core features, such as the vectorized query processor, new methods like factorization, Morsel-driven parallelism, and novel join algorithms that are specifically deployed in Kùzu. And you can read more about this on our blog at blog.kuzudb.com. So the final point to note about Kùzu is that the idea that we're trying to bring to the table is we want to bring structures to property graphs. If you've ever worked with other graph systems, the property graph model is called the label property graph model, or the LPG model. And the idea of a label is essentially what a node is, what entity the node represents. So here you have a person label and a city label. So what Kùzu does is it kind of redefines that using a structured property graph model, where instead of a label, you have a table. And a person table is kind of an analog to a person node in a label property graph model, as is a city table. And the relationship table is analogous to a labeled edge. But the key innovation, or the key additional feature that we're bringing to the table, is the columnar storage feature and vectorized processing. Because the data is stored in a columnar fashion, we're able to process the large amounts of data in blocks, and the vectorization can be applied at scale, which is in contrast to a conventional LPG system where you have a record-based storage and you process one tuple at a time as opposed to blocks of tuples at a time. So with that bit of background in mind, I'd like to maybe pivot towards what graphs are doing in the world of RAG. And I'm glad actually we had this talk after the previous one, because the basics of RAG, I think, are pretty well covered, in the sense that we know that LLMs have the following limitations: the outdated knowledge aspect, where data does not stay in sync with the real world. Hallucinations are one of the biggest issues with most RAG systems that people are building. And I should add that hallucinations can be of various types, but it could lead to any of these issues, from incorrectness, irrelevant information, toxicity, bias, and so on. And the other big issues with what people are seeing in their RAG systems is that there's a lack of transparency in the output. You don't really know why a particular result was obtained. And unreliable reasoning of LLMs. You know that LLMs can reason to some extent, but you cannot be sure that they understand themselves what they're reasoning about. So the idea of RAG is that you want to mitigate these issues and tackle these challenges using a system-specific design. So it's important to note the stage we're in right now. We are in a stage where RAG has evolved away from, you could call it, the naive form. And in fact, this is a term used in the literature now. There was a survey paper published in December of last year, which talks about the original RAG systems, which came out in maybe about a year ago now. So the idea is that you index vectors, store them in a vector store, send a prompt, retrieve them, send a prompt to an LLM, and use that as context to generate a response. Now, in most cases, that does a reasonable job. But as systems evolved and as use cases evolved, the kinds of queries that people are asking became more and more complex. So you go into the second stage here, which is advanced RAG. And there are many ways of describing advanced RAG, but the key point about advanced RAG is that you have a pre-retrieval stage and a post-retrieval stage. And there's a lot of additional steps being applied both prior to retrieval and after retrieval to improve the context for the retrieval stage, as well as the context passed to the LLM prior to generating the natural language response. So the point here is that we've even gone one step beyond that now with modular RAG systems. And what that means is essentially you have additional components now. For example, DSP is a big one that's coming out, where you don't necessarily prompt things using natural language. You actually use advanced prompting strategies using programmatic methods. And of course, agents and routing systems are also evolving along the way. And there was another really interesting paper that came out a few months ago about the trade-offs when you grade the output of RAG systems. And the grading is obviously a very subjective thing. You don't really have a fixed, clear-cut way of saying a result is good or bad. That is dependent on your domain. But what this Aragog paper does really well is it goes through a variety of classical vector database retrievals. And the one on top here is the straightforward one, which is classic vector database plus naive RAG, which I just showed in the previous slide. But obviously, there's things like re-ranking now and additional methods being applied downstream. And there's a wide distribution of your retrieval precision across these different methods. The point being, if you look at the right side of this slide, is in an advanced RAG system or application, there are a lot of knobs to turn. And typically the 3 axes around which you're trying to improve your system is along the lines of retrieval precision, latency, and cost. And many of the times these conflict with one another, so there's trade-offs to be met. So this is kind of where I'm hinting that knowledge graphs are becoming more and more important. And empirically, it's becoming very clear that knowledge graphs are playing a really important role in upcoming RAG. And this same paper that I just cited before has in its conclusion section exactly these points, where improving the contextual relevance of a RAG's application and enhancing retrieval precision is something that could benefit by using a knowledge graph, with an integrated knowledge graph. Now, that doesn't mean knowledge graphs replace the underlying vector store. All it's saying is that it's an integration process where knowledge graphs can enhance the system. And of course, when they end by saying it justifies further investigation, which I think means that a lot more work is yet to be done, and we're going to see a lot more on this. So the standard approach of using graphs in RAG is using a high-level query language, text to high-level query language pipeline. You could do a text to SQL or the language cipher that I just showed, text to cipher. There are also RDF graphs that use the Sparkle query language. All of these are high-level declarative query languages. So the general workflow would be you have a query in natural language, who is the top paying customer in Toronto. You essentially pass that to your retriever. That's converted by an LLM into a cipher query, like as shown here, where you retrieve every customer and their purchases, sum up their purchase costs, and sort by the maximum value. All of that could be done in any of the conventional stores, either a SQL store or a graph store, depending on the complexity of the query. And the output is essentially sent to an LLM as context to generate a response in natural language. So this is obviously, you could call it the graph naive version of a RAG approach using graph. And Kùzu indeed does have a LangChain integration that does something along these lines, where you have a text to cipher pipeline. And the benefit of using Kùzu in this kind of a system and this kind of an approach is that it's embeddable. So what that means is you don't need a server. All you do is pip install Kùzu and connect it to a LangChain pipeline, essentially use it to an LLM to generate a cipher query, and you're able to generate a response in natural language from the system. So this leads to a slightly higher level question. Are LLMs at all good at generating cipher or Sparkle or any declarative query language for a graph? And most existing literature that we've seen that use LLMs to generate any sort of query is in SQL. And that is obviously for historical reasons, because SQL has been around forever. We don't see too much literature on prompting strategies for graph database query languages. Though there are plenty of blogs and example code that you can find online, there is no rigorous sort of analysis that is done to say, with this sort of a strategy, you're going to get a certain level of response. And the main reason this is important is we know that LLMs can misunderstand relationship directions. When it comes to graphs, the meaning of the direction in the relationship is extremely important. And that is encoded within the schema of the graph. So we need to be able to understand whether the actual schema is being interpreted by the LLM and being used to generate a query that actually makes conceptual sense. And if you know Neo4j, which is a well-known graph database vendor, their approach has been to crowdsource labeling data for a text to cipher. And they're using that to fine-tune LLMs that can generate better cipher. Now, that's a promising direction, but we also know that LLMs and RAG is very, very prompt sensitive. And we're in an age right now where we don't really know how prompting is going to be a sustainable way for people to build reliable production applications. Subtle changes to prompt contents, like for example, you have this hash or the pound symbol surrounding certain parts of a prompt, or line breaks in certain locations, significantly affect the output of the LLM. So, and there's plenty of studies done on this. So the bigger question to ask here is, is text-based prompting a good strategy for querying at all? And if you observe the work that people are doing with DSPy, which is a different approach to prompting, it's a programmatic way of doing orchestration of all of these workflows. It's showing far more promise in terms of generating or providing more reliable outputs from graphs. Now, going back to the advanced RAG idea, the place where knowledge graphs are highly relevant are where I mentioned the pre-retrieval stage and the post-retrieval stage. So the pre-retrieval approach, I'll go through each of these in a bit more detail, and I think having examples will make this a lot clearer. So I won't go into each of them now. I'll go through each slide individually. But essentially, the idea is that the knowledge graph can be injected into either of these stages of the pipeline to significantly improve the output in different ways. So the first one I'll talk about is the document hierarchies. This is also called the parent retriever, if you read the Neo4j blogs on this, which is basically an advanced RAG retrieval strategy. And it's also called document hierarchies by the folks at Waihao. But the idea here is your actual data, the raw data, potentially has hierarchical relationships, not only within the text, but also at a higher level between the documents themselves. And I'll illustrate this with an example here. We're trying to answer a question about data privacy regulations in Canada. So imagine a data set where you had PDF documents about data privacy for many countries, of which one of them is Canada. And your question is specific to Canada, so you expect that your vector search would semantically match on Canada mentioned in the text. Now, that's a decent starting point, but in this example, we have two data privacy laws, PIPEDA and PIPA BC. One of them is a federal regulation, which is at a country level, and the other one is at a provincial level, which is like a state level regulation. And it's not necessary that the state level regulation document mention the country. So your vector search is very likely to fail. It's likely to miss that piece of context. So the idea where a graph comes in is instead of encoding the data naively in a vector database and just dumping the chunks into a vector store, you would link the document hierarchies themselves. You would know that data privacy laws have Canada, and Canada has provinces, and you have file names or other metadata information that links these documents together, and you would store those edges as explicit edges. And when you do a vector search, you would pass the traversal of the path of these document paths to the query to say that, okay, now that you've searched this document, search its children documents as well. So this is a way of enhancing the context of your retrieval in a way that potentially gives the LLM additional information to generate the response. The other key area where graphs can really be powerful is using them as a substitute for unstructured text to begin with. So you have a bunch of frameworks or APIs today available that allow you to extract triples of knowledge graphs from the unstructured text. So start off with raw documents, you extract the knowledge graph triples, which is basically nodes and entities and edges. And you could do these with various frameworks, diffbot. There's also a Waihao SDK, Llama Index provides one as well. There's many methods that you could research to do this. But the idea is once you have the triples, you organize them into a structured representation in this form. And the benefit of this, as you can see in this example, is you have Canada, which is a country, you have regulations, and you also have Quebec, which is a province of Canada, connected to the country. So if the question involved the country, you can backtrack and generate a path from the country to all its provinces and actually use a graph to inform where you need to actually run the vector search. So this basically allows the discovery of entities that would be very distant in your pure vector store, which allows you to expand the context of a downstream step. And one of the ways people are doing this is explicit chunk linking, where instead of storing the chunks arbitrarily and indexing them in a vector store, you would perform this simultaneously. You would essentially search the k nearest neighbors of a vector search, like a conventional vector store, a vector search, and also search the neighborhood of the same nodes in the knowledge graph to retrieve the chunks. And in this example, The knowledge graph, again, augments the vector search. It's used as in conjunction with the vector search. So using this path traversal, as I just mentioned, you're able to retrieve things that were not mentioned explicitly in the text or even semantically linked with the query itself because of the structure that is encoded in the data. So that's regarding the pre-retrieval. The other things, the other steps where it's useful are post-retrieval. So one of these is response augmentation, where sometimes you have information that is highly specific, and it does not directly exist in the vector database. So an example here, as mentioned in the YHub blog, is finding a drug that can treat Alzheimer's. And if you just vectorize this and look for Alzheimer's in your data, you will find a portion of your result. You would find, Alzheimer's. You would find a drug that's potentially related to it, even if they were far apart in the text. But adding a knowledge graphs gives you an additional layer on top of this. You can actually have not only if you see the structure of this graph, you have the treatment that is connected to the disease, but you also have clinical trials that are connected to the treatment. And in those clinical trials, you have side effects. So things like displaying a disclaimer alongside the response are very important in the legal domain or the healthcare domains. So sometimes knowing what disclaimer to present can be done very easily using a structured source like a knowledge graph, as opposed to relying on a vector store that requires additional steps to perform that retrieval. And the final thing I'll show here is the rule-based elimination approach, which is how do you enforce consistency and factual accuracy in the response once the retrieval is done? And part of this is to reduce irrelevance and hallucination. So this example shows if you have a query related to going for a vacation in a particular month where it is warm for a certain price. And obviously, it's a very complex query, so there would be some query reconstruction required in this step. You would not just vectorize this and try to retrieve a response. But what you can do additionally on top of that is send the query to a knowledge graph instead, send it to a graph database, where the knowledge graph has encoded within it things like the price of a certain place, the average price per trip, things like temperature ranges, additional information that would be hard to expect an unstructured retrieval. And in this example, Panama and Iceland are the two countries. Now we know one is warmer than the other in the month of August. And the data has things like Iceland hot springs. So a pure vector search that looked for a warm place might have incorrectly hit upon hot springs as a relevant response, even though it has no relation to warm climate at all. So this is a sort of context that can actually corrupt the retrieval, and that has significant impact downstream on the generation stage. So I know I've spoken a lot about the different parts of the pipeline in which graphs can play a role, but the idea here is, I know there's an AI engineer summit happening in the end of this month, but if you see the way retrieval and in general agents are going in the space, there's a lot of scope to incorporate knowledge graphs as a part of the advanced retrieval pipelines. And agentic systems are going to be, in the future, I presume there are going to be a lot more use cases where graphs are being used as a part of that retrieval stage, as well as the routing and the query planning stage. The question that came in the previous talk, which is RAG dead? I think everyone is going to expect my answer here. The idea of advanced RAG means it's greater than the sum of its parts. And long context windows, RAG, and fine-tuning are likely to exist in harmony with one another. There's a lot of people talking about this, why structured representations of knowledge are important in workflows, and they enhance the context, and they can assist better workflows while also using fine-tuning along the pipeline. The other final point I want to wrap up on is the harmony of embedded databases. They're very harmonious with other data formats and data systems. And the interop feature of these databases is a real big asset when building these complex pipelines. And the three systems I'm mentioning here, DuckDB, Kùzu, and LanceDB, they represent the different data modeling paradigms. They represent the relational model, the graph model, and the vector database model. Of course, there are other systems that do these same tasks, but what separates these systems from the others, in my opinion, is the fact that they use Arrow, which is a columnar data format, as a unifier. And this allows you to seamlessly move between these data models without actually having to copy the data between these systems. So we're really rethinking how these tools talk to each other, interacting with the raw data where the data itself sits, whether it be in data lakes or databases or other data formats. And I've blogged about this in the past as well, but I really think the space has evolved in a very different way. And there's a lot of different tools out there now that do things in an interoperability fashion. So the takeaways from knowledge graph and RAG perspective is that the idea of graphs is not new. They are slowly coming back into the forefront of people thinking about RAG. And the key word here is determinism. So I've been following the work of companies like Waihow. In fact, they're here in the audience today. Cogni is another one, Structify. These companies are actively using knowledge graph data pipelines. And the goal is to introduce determinism or improve the idea of deterministic systems. And knowledge graphs play a key role there. Also, advanced RAG methods are rapidly evolving. And as I mentioned, a knowledge graph can be injected at different points in the system to gain value. But at the same time, the literature is also evolving. It's definitely a younger field than, I guess, LLMs for now. And the studies on benchmarks and performance and quantifying how much improvement comes through these systems are still ongoing. But I fully expect that we are at a stage where it's becoming mainstream. So we expect to see a lot more work on this through the rest of this year. And from a Kùzu perspective, I'd like to summarize and finish this talk by saying Kùzu is an easy-to-use graph database for analytical applications. Think of it like DuckDB, but for graphs. What's really interesting about these systems, and Kùzu specifically, is that it scales to really large graphs, yet it's flexible enough and portable enough to work on many, many small graphs. And the idea of modern data systems is that you don't necessarily need one large graph. You might need many small graphs. How flexible is the modeling strategy? So Kùzu supports a property graph and RDF model as well via a Cypher query interface. It's embeddable in applications via multiple language bindings. And of course, interoperability is at the forefront. It's highly interoperable with the Python and AI ecosystem. So yeah, that covers my talk. I highly recommend to pip install Kùzu and to get started. Kùzu is open source. We are actively looking for people to build on top of us. And it's a system that essentially is ready to be used mainstream. And we're trying to get the word out there. So yeah, give us a star on GitHub, follow us on Twitter, and you can join our Discord community on kuzudb.com/chat. And also, of course, our blog and our docs on these links. So yeah, thank you very much.
Thank you, Prashanth. Any questions for Prashanth? I see a hand up there.
Yeah. So we saw the word harmony and determinism. Those are great words. But the history of hand-built networks has been brittleness. And so do you want to talk a little bit about how knowledge being brittle in the old, psych and all these other things?
So you mean expert systems, right?
Yeah, but networks, building hand-building data has had is one of the things we're kind of loving getting away from sometimes. And so that harmony might be the answer. But what do we do to stop the brittleness in these data, mistakes that always occur
there's no doubt that getting the data into a form that you trust your representations in the graph is not an easy feat. I mean, there's a lot of companies spending a lot of resources on this. But I think if you look at the way people have been building graphs historically, they've relied on a combination of structured sources and a lot of human input. But I think this is why LLMs have kind of come back and brought graphs to the forefront, because if you look at the trends of how people are searching about these terms, it's very clear that graphs are experiencing a resurgence right now. And although there's a lot more work to be done, I think there's a lot of promise in applying some of these methods, including LLM-based extraction tools and custom, rule-based approaches to filter out certain incorrectly identified data sources. Like Llama Index just has done some work on this in the last couple of weeks on this. So I feel like we're at a stage now where people are actually using automated tools to help build these systems, but also using them to verify and with some human in the loop feedback. So the amount of manual labor and work involved in vetting these systems is definitely something that's going to reduce with time.
Any more questions? I'll ask you one. Okay.
So based on what you presented, the RAG with knowledge graph, so I understand there are two databases. First is the vector DB, which store the embeddings, and the second is the knowledge graph itself, which store the hierarchy. How are you linking the two, especially when the hierarchy keeps increasing with increase in data?
So yeah, there definitely is a data maintenance sort of workflow where, yes, hierarchies change, your document structure may change, but for most situations, you can imagine that you have a business problem that you're trying to answer, you define what data currently exists, and you augment your existing data with new data as it comes in. So the schema definition stage is really, really important. So typically systems don't enforce schema, like graph systems don't enforce the schema, but the way to think about this would be you identify how these documents are connected, how the data actually goes through this from end to end, and you have a sort of high-level schema that allows the developer to know how to evolve this over time. And the data is only ingested and stored and indexed if it adheres to that schema. So it's an upstream step.
So that applies to knowledge graph, but then when you are querying to the vector DB, you only pass the natural language. You can't pass the entire hierarchy, right?
Right. So you would pass a document ID. So the vector store would have a metadata field that has a pointer to the the document ID, and use then a graph query that traverses the document ID's connections in the graph.
Good. Thank you.
Any more questions? Okay.
I was just curious. I've actually been doing some work on turning natural language into gremlin queries. And are there any like models that you found work better? Like I've gotten decent results, but not, I think, kind of running into the same thing you were talking about before, where it's not perfect by any means.
Yep. So I think the real challenge is how do you reproducibly generate queries that are syntactically correct and also answering the actual question. I think fine-tuning is helping to some extent, but I haven't personally fine-tuned models for this. I know Neo4j has done a lot of work in open sourcing some of the data sets that people are using to fine-tune models. But as models evolve, the idea of what a good model for cipher generation or gremlin generation changes. So this is something I feel like will keep on evolving, where people don't stick to one kind of model or one model. They would have a continuously improving pipeline where they keep updating the base model and then fine-tuning that to actually generate the queries that they need.
Cool, thanks.
Yep.
Thank you. One last question, if there's any more. Any more? I don't see any more hands. Thank you. A huge round of applause for Prashanth. Thank you, Prashanth. And I think we can call on the next presenter. That's Brian from Korbit.
Hello, everyone. Just wake up a little bit. If you want to stand up and stretch, I've been sitting for an hour or so, so feel free to do that or not. Let's get going. So yeah, my topic is all about doing PR reviews with AI and generative AI. specifically in GitHub, in this new world we live in, where I think probably the biggest application of GenAI right now and where they're targeting most is clearly at us, software engineering, and they're seeing great benefits of it. So full disclaimer, we do provide a product that does this very well, but this is not going to be a sales pitch about that. But I would like to talk about everything we learned. So I talked to probably hundreds of companies as we were looking for a product market fit and go-to-market strategy, and just got a tremendous amount of feedback and a lot of trials and tribulations as we were developing our product over the last year. We just launched it about 2 months ago. So a tremendous amount of learning as we were perfecting our product to launch it into the world and help software engineering be more productive and accelerated. So my background is I was a software engineer, and former should probably be in all caps because it's been a very long time, but I was educated as a software engineer. And then opportunities and people just dragged me elsewhere, unfortunately, because I really like doing it a lot. Now I know enough to be dangerous, but if I get in that lane, you'll kick me out of it very quickly, especially if I start saying like, shouldn't you, yeah, I'll get thumped. But I've been a CEO multiple times in really all the disciplines of companies, and have had the fortune of doing what I really love, which is building software products and bringing them to market, figuring out problems that we can solve in the world, and really focusing on that tremendously and delivering products that do that. So it's been a great time in our beautiful city here. Just real quickly, Korbit. So we're a startup based in Montreal, Canada. However, I'm here. We're about 20 people, and I think 2 of us are not engineers. The rest of the team is all engineering, which is fantastic. But as I said, we're going to market now. Probably the biggest metric on here that stands out, if I would look at it, as I said, I just went to market 2 months ago, founded in 2019. So we did start as a AI-based e-learning product. And we were helping software engineers then as well. And we were trying to really understand your interaction with the training material, your pace, your knowledge level, accelerate, decelerate, take you elsewhere, give you exercises dynamically, and really engage the people. When GenAI came out, we really saw an opportunity to do something better. And that is to figure out when and where someone needs training or help in their workflow, and then provide that to them in their workflow so that they can fix the problem that they're having, but also learn along the way. We raised our Series A with Coastal Ventures on that premise. So again, very simplified development process here obviously is you're writing code, and then what we're trying to do obviously is merge it into production is obviously the goal. And there's a big gatekeeper in the way, and that's the review process. How many folks here do PR reviews on a regular basis? Yeah, a lot of. How many like them or feel that they're efficient? Or nobody? Anybody? Nobody? You're like, okay, yeah. Again, I'm going to take like anecdotes from the people I talk to. It doesn't necessarily represent you or your experience, but we're definitely going to focus on this stage of the process. So here's what we see that's going on right now. It's clearly essential, and it's usually a bottleneck. Not usually. I found that it's really always a bottleneck. There's delays. It's really expensive. It's expensive, namely because the person that is doing it is a senior staff engineering manager level person, and they would probably expenses not only their pay grade, but also the opportunity cost of them not doing other more advanced things, and slow is obvious. And then ineffective, I won't pass any judgment, but what I've found is yes, usually, meaning like stuff slips through. We have biases. It's like, oh, it's, Sally who, did the PR, and I know Sally, so I'm just going to let this, I'm too busy. I don't have any time. So we're pushing stuff through, and a lot of stuff gets through the cracks essentially. So they don't get done. at all, or they don't get done well. I don't know if that's your experience, but again, that's what we're seeing out there. And what does it take time? So as we just talked about, it's like, you know, pretty serious engineering skills, and you really got to have context. So it's not just about the PR that was submitted. It's like, what is this about? Sometimes the dev doesn't even know, but the staff engineer, the peer reviewer needs to know, how does this fit in? How would it affect other things? What is the context? You know, what are we thinking about in the future? Will this support where we're headed, not only where we are? It takes a lot of patience, and you got to grind through a lot of stuff. And a lot of times it's just more than we have the willingness or capability of doing. And then lo and behold, what shows up is, you know, the first, I think, AI, GenAI product to really hit software development is in the code writing process. So we're getting code completion and code writing, so we get more code faster. And while those products are good, I think what we see is a lot of times, you know, the code that is being accepted by them, they may or may not know what it does, but it works, so they pass it on through. And the staff engineers, I think we're just hearing that, you know, or the reviewers, I should say, are waving the white flag more than ever. It's becoming more of a burden and more of a bottleneck. So with the platform that we built, which was to detect when people need help and help them, guide them to that help and to a resolution, we found that this review process is a perfect place for a GenAI product. Obviously, it can just rifle through volumes of code. It can pick up the context. You know, it can detect these issues. Some are easy, and we'll talk about that, little nits and styles and stuff like that. But these things are impressive, and they can also detect issues that are complex and require analytical thinking and reasoning in order to understand and surface. You know, they're unlimited, so it's not waiting. You know, a lot of times we'll hear that our PR process, we try to review a PR within 24 hours, you know, and that's their goal. It's kind of like a support ticket. These things review right away, and and as a matter of fact, it doesn't require a PR reviewer initially at all. This thing is completely automated and autonomous. Not through to merge, don't suggest that, but it can do the initial set of eyeballs and a set of eyeballs to get the dev some feedback and more independent. And of course, the more it does, the better it gets. So it is learning. It's learning not only about your projects and products, it's learning about the developers. Who's good at what should I pay more attention to based on that? And what should I look for? And of course, it's loyal. It will never walk away with this wealth of knowledge that it has about your team and your practices and your products. All good stuff. So the benefits are clear. You know, we're all, well, the engineering managers and VPs of Eng and CIOs are looking for shortening and reducing the cost of their time to merge. You know, we want to ship product, we want to ship better product, we want to ship more product, and that is obviously what this will allow. So just talking about, again, what I talked about the onset, and the two earlier presentations, I think, touched on a lot of this. It's, you know, it's not just a matter of just taking your PR code and handing it to an LLM and saying what's wrong. We all know what that will cause. And it's what we saw, because that was our first deliverable, our probably pre-alpha product. And it was just a lot of noise, a lot of hallucinations. It was clear that the results that we were giving were more of a pollution. And while you could sift out some gold nuggets, it was kind of like we're handing you a bag and full of nuggets, and 90% of it was or coal. And there was, like, you know, maybe 7% was silver, and then there was a little bit of gold in there. The encouraging thing for us, though, is that those gold nuggets got people super excited. And when they saw those, they were like, you guys are onto something here. And this can really help us in our software development process, both in terms of accelerating it and ensuring higher quality. So what do we try to do? This is not necessarily an order or exhaustive, but if we started building our guiding principles, and what we thought we would want is like, what is a perfect, PR reviewer? It's, something that I think is probably not possible with just a human doing it. So the first few are easy, but we really wanted to plug into the existing workflow. GitHub and others have great PR processes. They're established, you know how to use them. So we just wanted to appear in that process just as if we were a PR reviewer, a human PR reviewer. So you submit it, you tell the PR reviewer, the AI PR reviewer, that you want a review, and it just does it, writes it in the comments, and right into the PR, and gives you explanations, feedback, and examples of how to fix it. The accuracy and relevancy is something we spend a tremendous amount of time on. Of course, super important. Again, nobody wants those coal. And what we were learning is if we were handing things up that were not accurate, a lot of times you would read it, and it's not just a couple of seconds before you determine that it's not something that's correct, that it's a hallucination. You could go down a hole and spend a half an hour, and obviously that's super bad and nothing that we want to do. The other nice thing that we wanted to provide is the visibility and insights, and I'll give you an example of this. So what are all the activities that are going on with the PR reviewer? Who's creating what kinds of issues? Again, not trying to be big brother here, but it's really helpful in understanding the state of your product. So if you say like, hey, we're supposed to ship in 3 days, you can look at your PR reviews and see what types of issues exist in the code right now, who's creating them, what do we got to do, what should we focus on, what should we just let fold. So it's just like you're telling your PR reviewers, like, hey, don't flag little nits in the reviews right now. Just find the stuff that's going to crash the system, security vulnerabilities, maybe some big performance things, but we got to ship and we got to go. And that's kind of control and filters you want to be able to do. And then the mentoring is really important too, because we talk about lack of time. So it's one thing to catch these issues and flag them and tell the developer that, it's not going to merge with this stuff, go fix it, or recommendation, but it takes a lot of time, the explaining and the teaching, but it's super valuable because you want obviously the dev to learn what they did wrong and how they can avoid doing it again. So the upskilling is super, super important again. So this is way out of my league, but it was kind of fun to hear about the graphs and stuff that are going on because I hear about it all the time. But again, this is just not about passing some code through an LLM. We've built a commercially viable application that is in about, as you saw on that first slide, we've got about 150 customers that are using Korbit in their production software development processes. So the PR gets submitted and we take a good hard look at it. And then based on what is requesting in the project, we gather a bunch of context. So it's what other related files, libraries, databases, the team, the organization, everything we can get our hands on. And we do a lot of stuff with that. I think some of those graphs are probably what happens. Then we start generating the issues via the LLM. So we're hitting the LLM with all this information. And this is where, again, the prompt engineering that we heard about in the first presentation really hits home. So it's like very complex, iterative interactions with the LLMs to get the kinds of issue quality that we want. And then we do a bunch of work again to give them severity and confidence scores so that when we start to present them, that we know what to show and what not to show based on these scores. And then, as I said, it goes right into your PR. So we flag the issue and we explain it. I can show. So here's a PR in GitHub. kind of a funny example. It's a little dated, but I can't take customer stuff. So this is something that I'll pick on Antoine, who's on our team. But Antoine basically, submitted this PR, and then Korbit says like, hey, I'm looking at your PR, it's happening, and I found some issues. And here's the issue they found. And I can even remember this from like probably my computer science 101. He's got the total line within the loop. So Korbit identified that. It says like, hey, bonehead, you're going to come up with the wrong number here because the total is within the loop. And then Antoine, which I had to have a little talk with him, like, was this really late at night or something? He said, why is that a problem? Can you give me more? And as you can see, Korbit can be interactive as well. So if the issue that we identify and explain to you, and you can, like a person, you can say, hey, Korbit, tell me more. And as you can see, it gives more explanation, and it gave an example of the code. And Antoine said, thank you. And I think it said, you're welcome. And we move on. So, again, it's security vulnerabilities, performance, optimization, critical errors, just a whole library. And then, as I said, being able to control this, what you have the ability to do is toggle these things on and off. So basic categories of issues that you would like to focus on or ignore, depending on where you are or who it is, and what you're trying to accomplish. You just choose a repository basically, and then anyone who submits a PR within that repository, we automatically scan that PR. So essentially what we're trying to do here is obviously PR reviews going on, and you've got things like linters, and they're catching errors and nits and consistencies and policies, and we can assume all that stuff. But what Korbit as a company is most focused on are the higher value, more complex issues. We think those are the ones that give the most value to the teams, and have the biggest impact. So again, these complex issues, we identify them, and then we teach the devs about them and help them resolve them. So, we're seeing pretty tremendous acceleration and productivity on the dev side. And then also, again, maybe as important or more importantly on the PR reviewer side. Oh, we already looked at that. Oh yeah, and then the insights I kind of skipped over, but we do track, the PRs and the number of issues, and it's all the way by developer. I kind of put a stripe in the PR author's name because to protect the guilty, I guess. And we track the resolution rate. So you'll be able to see for the issues that we displayed in the PR, which ones were corrected in the PR. So you get this nice success metric, and then you can derive, again, the value of that. Obviously, time savings, but keeping that bug out of the production system. And here you can see, this is just a simple graph that I grabbed. The critical issues that were in the PR and the security issues that were in the PR, and who did it, and it will highlight it. And then again, little talk, little focus, little training to upskill these people specifically on what they're needed, unbiased and ready to go. Again, just a lot of feedback from our users on what they've seen, specific bugs that we found or issues that we found in their code, and how we help them resolve them. And again, I think we talked about this, but just the real benefits. I think like one big takeaway is with these tools, it's early, as you guys all know, you're playing with these GenAI tools all over the place, but just, hang in there a little bit. So install this thing, you might run it, and or anyone, maybe it doesn't find anything for a number of PRs, maybe it finds a ton of stuff, but it'll all kind of start working itself out, and you'll start seeing If you work with it just like you would work with a team member or a colleague who's in this role, with a little coaching and a little hugging and help, it becomes a big productivity gain. So the engineers, they can find and resolve the issues by themselves. The seniors, obviously less time. And then just that time to merge, again, I just get beat with that, is like increase the time to merge for the VMs and above. Better code, reduce all overall code debt, finding the things that matter most to you. And then a big one that is kind of, again, maybe a byproduct of what we're doing, but clearly upskilling the engineers as they work. So really teaching them the concepts and techniques on how to improve on the issues that they're having. And then the visibility into your projects and your teams. So you know what's going on exactly and how you can, what you need to do to improve or hit the deadline or improve your team's capabilities. Securities definitely comes up a ton. We're not SOC 2 yet, but we are working on it. But we do have a zero retention policy. The code clearly passes through. We pass it down to LLMs, including OpenAI. We have a zero retention policy signed with OpenAI, so they don't retain any of the code either. Never train on any of the code or any of the data. And our team doesn't have access to your code, but we see the issues that arise out of it as you saw. And we have a 30-day free trial going on. It's unlimited, so you can pop as many developers as you want, as many repos as you want, run as many PRs as you want, yeah, give it a go. And then if you do sign up, you'll get a welcome email from myself. And I'd love to hear from you. I'd love to get feedback. It invites you to schedule a meeting with me if you want and talk, or you could just reply to the email and let me know how it went. It would be much appreciated. I think that's it.
Do we have any questions for Brian?
Thank you for the talk. From the previous slide on security, I understand that your solution cannot be hosted on-prem, right?
I'm sorry?
Does your solution can be hosted on-premise, or does it have to?
It is not on-premise. It's in the cloud only.
Okay.
So it's in the GitHub Marketplace, I should mention. So you can find Korbit in the GitHub Marketplace. It installs as an app on GitHub. And then, as I said, in the install process, you select the repo or repos that you would like Korbit to operate on. And then when a developer who's part of that repo authors a PR and submits a PR, we automatically scan it. But we're only on GitHub supported right now. Bitbucket is coming, and then Azure, and probably with Azure is when we'll be behind the firewall.
And I don't know if I can pronounce that name here, but also GitLab, maybe. Don't judge.
Yes, a GitLab. Sorry, that's actually right after Bitbucket. Yes.
Thank you.
Hi. Do you find this works particularly well on one area of development? Have you seen, and then have you seen any emergent properties you didn't expect in terms of interesting solutions?
So we are seeing more like it works. It's language agnostic, of course, because of the LLMs that we're using. We do most of our testing on Python and JavaScript and TypeScript. I would say it's definitely stronger on kind of back end type code versus front end, where you kind of need to see UI to be more effective. It can't do that stuff. And what was the other question?
Anything interesting you've seen emergent from as this process went that you didn't necessarily expect?
In the budget?
Emergent, sorry.
Oh, nothing that comes to mind, actually.
That's okay, thanks.
Okay, we have time for one more question.
There's somebody up there.
Thanks. So we use SonarQube where I am, And the downside of that is it's great at capturing all the issues. The next step is convincing developers to go and fix them, even though you're always on a tight deadline. Have you considered integrating like a confidence level with this, where if you're sure that this is a bug, you just have the reviewer go in and change it itself?
Yeah, so the severity and confidence levels is something that we spent a lot of time on. And we do expose those in the PR. So you'll see, like in that example I showed, it was I can't remember if that was old terminology, but right now it will now say like severity 1 through 10 and confidence 1 through 10. We started masking that, but we give you the ability in the console where you saw those toggle switches to say what level of confidence and what level of severity issues you'd like to see in your PR. So again, if you're in crunch time, you do have knobs and dials. Again, we're going into a black box, as everybody knows. But if you're going into crunch time, for example, you can turn off all the things like style or whatever things you don't need to fix, and you can set the confidence at a pretty high level, and it works out pretty well. And then you can, you can always dial the numbers down and rerun the PR. So we've seen things like that go as well.
I guess you've got some low-hanging fruit that you could really easily fix. You're like, this is a typo. This is like that loop example. Would you consider over time getting this to actually implement those fixes itself?
Yeah.
And go, hey, I've made this change for you.
Yeah, I would say so. Yeah.
All right. Thank you, everyone. Let's hear it for Brian.